In this video, we will finish up the example 8 from the packet and find the future value of the annuity because we already found the present value first. So to find this, again, so in summary, I could either use the raw formula we just proved, or we could use the abbreviated finance version, which goes something like this. S is equal to R, which again, Joe put in $200 every month, times, instead of little a, it's little s, 36 bar 0.005. And this should give us, excuse me, the future value of that entire annuity, almost like magic. And again, historically, this may have been looked up in a table, but we can just do the math by plugging in our P and N into our formula. So in the same way, we've already done N and P from a minute ago. So what that would amount to in this case would be 1 plus P is 1.005 in this case, to the nth power minus 1 divided by P. Very, very similar ratio, actually. And if we were to type all that into a calculator, much like before, to get the sum of the future value of the annuity, we would have 200 multiplied by that big heck of a fraction, which is 1.005 to 36 minus 1, and then divided by 0.005. So if you're losing track of what I'm doing, I'm just evaluating this capital S, which is the future value of the annuity, by typing in 200 times that, which is just given by this formula, plugging in 36 and 0.005, and that amounts to $7,867.22 for the future value. So also, if you kind of notice that the sum of just 36 payments of $200 is $7,200. That would be kind of like if you just made all these payments, kind of like on the test question, whereas I asked you, well, what happens if they just keep putting money under the bed? How much do they have? What's the sum of it given an arithmetic sequence? So, and remember that an arithmetic sequence is just one where there is no interest. It's just the same amount every time. Well, technically arithmetic could be simple interest, but let's not get into that because I'm tired. But notice that like the value of just the straight $36,200 payments is $7,200. The present value of all of that staggered over the course of 36 months is less so, because we could have invested the money so that it would grow to that net amount. The future value is also more so than that raw amount because each one of those payments is gaining interest. Like if we go back to the general diagram there from the packet, like the raw value is $7,200 without any interest, but each one of those payments is getting a different amount of interest because it's had a different amount of time to accrue. And thankfully, these formulas take all of that into account. So if we're trying to do this, we don't have to do the raw mathematics every single time. We can use the proven result more efficiently.